Okay, so I thought I would share a little bit about how I go about programming these parts that I run. This is a little short run that I have on some parts for the mill, conversion parts for the mill that are kind of standard parts I can machine ahead of time and use for all different kinds of kits that I machine. So these soft jaws, I cut some soft jaws one time before and done a video on it, and these are a set of soft jaws that are specifically for these parts. And you go in here and mill these areas out for the parts of the actual part that you're going to mill to fit in, and it will grasp that part tightly. In order to do that, you establish a set distance between the soft jaws, clamp that, whatever that may be, whether it be gauge blocks or a piece of material that is a specific width, and then you mill that out while grasping that object. So then when you put your part in, you get the correct dimension here and it holds it rigidly. The setup for the jaws, the machining of the jaws, I have this all in this one file here. Under the first setup, I have the machining of these surfaces here, which I just simply done a boring operation on both and created the ledges for the part to sit on. And then setup 3 is for a same size part, but it gets the sides milled off as well as holes in here. I'll show you. Here's the tool path for the holes, 4 holes, and then there's a contour on the side, mill the side off, and then a contour on the opposite side to mill that side off. And then in setup 4, as you see, it's the same size part dimensionally, but it has no milling operation. It just gets 4 holes that are equally spaced around the part at 90 degrees instead of the whole pattern here, which is closer together. So these parts are fairly, they are consistent with all of the parts required to convert a mill like mine, the Precision Matthews. So these parts can be produced ahead of time, and they'll work with any machine. Whatever the casting variations may be will be all in the actual machining of the bearing block itself. The bearings are the same size, so all of that will coincide with these bearing retainers. You can go back into your model and go back in here, and you can turn on those parts so that you can view them. Then you can go back in the cam and pick the setup, and you can see that's the part, and then there's the tool path in the hole pattern, and then on the contour, that's the tool path on that, and then there's a contour on that side, there's the tool path for that. Same thing for the other part, which is just round. It just gets 4 holes at 90 degrees apart. You can go back in your cam, and then you see that's the setup, same size part, and then it's just 4 holes 90 degrees apart. Use the same workstation. The work center coordinate here is in the center of this hole, so it could just load the part in, probe it, get the 0, and then get the tool height set and all, and then just run the program, and you can use the same offsets for the other part they are consistent. So you just load it up, run it, take it out. So that's pretty much the run on these parts, and I'll show the each one so that you can see it being milled in this configuration. This is the parts that I milled earlier. They get the contour down the side. The four bolt pattern here in the sides is a little bit closer together. And then it has a ledge to push on the bearing inside the pocket. And as you can see, it just snaps down in here. You can't get it oriented exact here, but when you load it in, it's round like this. It's just a round disc, and which these will be the ones with the 90 degrees apart. It'll just go in like so. Tighten the vise up on it. Make sure it's down good. You have to clean your fixture every time to make sure you don't have any debris laying in the bottom of it. And I will just give it a little bump just to make sure it's seated down good. And all I did was just ran the machine back to 0 on the part, which is actually it's in this pocket here. The next run is going to be 0 the same way, so I just run it back to 0 and then reloaded my program for this 4-hole pattern, which would require just a drill. So I'll get the tool changed out and we'll run this part. Okay, so I got the tool changed out. This is just a number 20 drill. Works well for a 4mm screw clearance hole. So this will just come in here and drill 4 holes around. I believe it'll start here and go around. And that'll be it. And then we just reload it and run another. Okay, so it's run the first part. You just clean off all the chips and stuff here out of the way. Pull it out, and there you go. Then you just set all them to the side. Get your fixture ready again. Then you just hit cycle start again. Well, I got 2 more to run, so I'll just run these out, and that'll be that run. That'll be the end of that run for those parts this time. Okay, thanks for watching, guys. The speeds and feeds on the drill. I just run a I did a chip break this time, just a 40 thousandths retract just to break the chip. You can see they get kind of long. Sometimes they don't come off this pretty. Sometimes they'll come off and they'll bird nest on the drill, and it scratches up the part pretty bad. So I normally don't like just running a steady drill cycle, because they even get long even at 40 thousandths. It's amazing how much material comes out of one little hole. But I just run about a 3.5 inch per minute feed rate on most of what I'm drilling. I could go higher, but my spindle RPM has got me tied down to 1700 RPM, so I try to keep my chip load on my drill down to about somewhere between 1.5 and 2 thousandths. It doesn't bird nest quite as bad around the drill bit. So and with that chip break, it works pretty good as long as I'm drilling shallow. But if I drill deep, I'll go with a full retract pick mode. I know it's not as fancy as a lot of the bigger machines will run. They'll run a pretty deep pass, but with 1700 RPM, it's hard to turn that drill bit fast enough to pull the chips out at a good rate. So even with your speeds and feeds matched as best you can, I mean, it'll still get jammed up in here in real deep real deep holes and stuff. So I normally just take my time. I'll just back it out so it don't weld up on the bit and break the bit, especially on the smaller holes. The larger holes, not quite as bad. It'll just stop the machine, and it'll just basically, if it gets that bad. I've never had it do it, but with the smaller drills, it'll just ring it right off, and then you got a problem. You got to get that out, or you got to ditch the part, one of the two. So it's always, I just take my time. I'm not in that big a hurry. But that being said, like I say, the feed rate is about 3.5 inches per minute at 1700 RPM. Gives me a chip load somewhere around 2 thousandths per flute per cutting edge, and 1700 RPM. So that's pretty much it. With a retract, I do a full retract for deep holes and 40 thousandths on chip break. It doesn't take much just to stop that chip. And the feed rate on the 1/4 inch end mill is somewhere around 8 and 10 inches. Usually is fine. Gives you like I say, around a 2 thousandths per tooth, 3 flute end mill carbide. That's what I try to stay around generally. 1700 RPM. I can't go so fast, so it's 8 inches a minute usually gets you close to 2 thousandths per tooth. And like I said, I'm not in any big hurry. And another thing, you're only holding on to so much of the part here, so being a little conservative on the side load on the part, keep it from moving or spinning or kicking it out of here. You had to keep that in mind as well. So nothing real heavy on it. When I milled out the soft jaws, I used a 1/2 inch end mill. I think I've got a 12 inch per minute feed rate on it. Same RPM, 1700, which is as fast as I can go. And it's a 4 flute end mill. So I could probably bump that up a little bit, say around 15 inches per minute. It would get me a little bit more chip load. It would handle it okay, but as I say, I'm not in a real big rush, so I just use conservative speeds and feeds. As far as the rapids and stuff, the machine, like I said, right around 200 inches per minute rapids. Retract on tools and stuff like that, I'll run about maybe 60 inches a minute coming out. That pretty much covers all the speeds and feeds. Normally it's around nothing over 15 inches a minute on any of the tooling that I have, because I'm tied down to my 1700 RPM for now until I get a belt drive going, and then I should be able to get on up into some higher feed rates, and possibly even carry a little more chip, because I would probably run a larger motor as well, so that I could get more power to carry the chip load, about a 2.5-3,000 chip load on roughing and stuff like that. Smaller chip load on finishing, just so that it would leave a better finish, and of course you would slow down your feed rate as well on a finished pass, so that would reduce your chip load as well. Okay guys, that's pretty much covers it. Appreciate you watching, and thumbs up if you like, subscribe if you like, and we'll catch you next time on the next one.